I think yesterday I explained a little bit about the parametric before going to the conic section. So let's get back to the parametric. Okay. So parametric means you will have another parameter or another variable. Usually we are indicating by t. The parameter is t. So it's called the parametric equations. The t is our parameter. And if you see here, x is t squared minus 3t, y is t minus 1. If we imagine t as time, okay, so imagine t as time. X, y will be the position. So the position will change with the increasing of t, position will change. So if you want to make a table like t, x, y, I start from maybe t minus 2, x will be it's 10, y will be negative 3, negative 1, 4, negative 2, and you do it as long as maybe 5. It's 10, it's 4. And let me draw what the graphs looks like. Let's say this is 10. This is 5. This is negative 3. Start from here. It's t equal negative 2. Of course, if you imagine t is negative 2 as time, it would be weird. But let's just say it's negative 2 to make the graphs equally or symmetrical. Let's say this is t equal negative 1. And when t is 0, the x is 0 and this is negative 1. So t equal 1, t equal 2. And then t equal 3 is 0, 2, 0, 2 is maybe. Okay, yeah, more or less should be symmetrical, but what I want to show you is you can make any movement based on how the t changes. Okay, so basically this is just plotting the t from any t you want. Okay, I'm using -2 because I want to make the curve becomes symmetrical. But I think my drawing is bad. Yeah, but okay. Okay, so based on these two equations, we can also let me move to another page. Okay, you can later you can complete the table by yourself. Okay, just putting the t from -2 until 5 to x and y. Okay. Okay. Now let's see this these two equations. Okay, x and y. The first solutions or the first method is we call eliminating parameter. Okay. Because if not, then the only way to sketch the graph is by plotting the x and y. But that would be really tiring, right? You are waste your time a lot of time to plot the graph. But what if my y is t minus 1, then my t is y plus 1, right? Okay. And my x is okay. And then my x will be y squared negative y and negative 2. Of course, if you get the y squared minus y minus 2, you can simply say this is parabola. And you can draw easily, right? So that's the first method to see the parametric equations in a xy formula by eliminating the parameter. Okay, another example is circular motion. For example, if your equations of x is and y is sine and t is greater equal 0, then how you sketch the graph? Of course, the first way is just plotting the t into xy and look on every t you can find. And because it's cos or sine, it will be circling. Okay? But rather than plotting the t into x and y, we can also use the eliminating parametric. Okay? We can square, correct? So x squared plus y squared, right? It will be cos squared t plus sine squared t, right? Which is equal 1. So we can graph this let me use the color. And this part will be 1, 0. Or let me make this y, this is x. Do not confuse with the polar coordinate. Okay. Now I'm using xy axis. Okay. Now we are in the xy world. Okay, not r theta. Okay. So this is the point here is 1, 0, meaning, okay, it's a little bit review. 1, 0 means 1 is for the cos, or in here is t. Okay. The 0 is sine t. This is where t is 0. Okay. Got it? And this is when t is pi over 2. Okay. And this is t equal pi. This is t equal 3 over 2 pi. I hope you don't get confused. And t is actually behave like a circle. So we can also say this is t, because all is fitting the conditions of all equations. So t is behaving like a angle. Okay. Another example, if you have x is sine t, you have y 2 minus cos squared t. So now we are here. So a little bit of analytical trigonometry is needed in certain equations, especially for the circular motions. So here you get the 1 minus sine squared t. So y will be 2. 2 minus 1 is 1 plus sine squared t, which is y is 1 plus x squared. Okay. So this form is parabolic forms, but remember, because x is sine t, so sine t minimum and maximum value is -1 until 1. So x will be from -1 until 1. So if you have the graph, let's say this is -1, this is 1. This is the maximum and the minimum x that you can apply. And then when you plug in -1, it will be 2, maybe around here, 2. So this is 1, so maybe around here. So it will be, it's actually circling like from here, going here, and then back. It's also circular motion, but it's not a full circle. Actually, for circular, there is also a certain. Let me draw this for you. Okay. Imagine this is when you're riding like a bicycle. If you have maybe, imagine this is like you're riding a bicycle. Imagine there's some point P here. And you go along the way, right? Imagine the P, right here. P goes along the circular motion as the circle move towards let's say x axis positive. Sorry. So let's say this is the move from going there. Imagine your point P. Okay. Let me draw another circle. Let me just copy this. Okay. And okay. So imagine from position 1 to position 2. Okay, so it's goes there. So move. Okay, like that. Moving the P. Imagine you are moving your P and maybe around here. Yeah, a little bit imaginations. Maybe the P around there. And make another circle if you want. Here, maybe here. And then the same light here. Maybe around here. Let's say, yeah, maybe around here. If you connect all the P, this P, connect there, and also connect there, the P will be having like, if you connect all P and all with all possible movement, this is what you will get. Okay? This is called the cycloid. So this is P. Say this is the center of the circle. Let me name T, and then this is the origin. This part is wait. Let's say the radius is A. They make another segments. Let's say this is C, the center, or maybe a bit black. The center, and maybe because it's P, that make Q here, this point. And then they make segment from C to T. And then let me make some segment here to illustrate that this is X, this is Y. And if we have theta here, let's make some equations to define the cycloid. Okay. First, we see this distance. This is let me write OT. And this distance. It's PQ. Okay. So X is OT minus PQ. Okay. See X here. So OT is this is the radius. This is the angle, right? What is this? The length? Yeah. Let me write as notes. How do you say that? Arc, right? The arc length, the arc, or I will write arc PT is A theta. Okay. So A is the radius. Okay. A is the radius. And let's see this picture one more time. Where's the first point of the cycloid? This origin, right? Moves until here, right? So imagine the placement of the ball or the circle is here at the beginning. And it's moving, right? So this point will move through here. So this segment is actually will be the same as the placement of this arc here. Okay. Okay. Let's say it's defined as that. So OT will be a theta. Okay. And PQ is just the radius and its sine, right? It's sine. It's cos, it's sine, right? So it's A sine theta. So for X, you get theta minus sine theta. Okay, so we define this X and Y to define what is our cycloid, okay, approach from the theta and the radius. And Y will be CT, right, minus CQ, okay? CT minus CQ. CT is just the radius, and CQ is the cos, right? A cos theta. 1 minus cosine theta. So parametric equations for cycloid X is A theta minus sine theta, and Y is A 1 minus cos theta. Okay, cycloid. I think you will meet the cycloid again later in calculus 2. Okay. Let me write maybe around here. So polar equations in parametric form. So recall rectangular dxy and polar. Let me move a little bit to the left. Are related by right? So we can graph polar equation R is functions of theta by changing x is r cos theta. We can change this to this form. Okay. Let me write the conclusion. So in parametric, you will have x is ft cos t, y is ft sin t. Okay. For this practice and example, I will send you some PDF file and you can have some exercise. But basically, the parametric and the polar usually the question is asking how to graph the sketch at least, and usually by eliminate the t, you will get the results, how you can sketch easily from eliminating the parametric t. I think that's the last part from the chapter 8. Actually, there's one sections 8.3. It's called the Moivre theorem, but I think you don't really need it now, so I'm skipping it. So basically, the Moivre is how we deal not only the real numbers, but with the imaginary numbers, how we can make a sketch from real and imaginary. So we will have in the x-axis the real number, and the y-axis become the imaginary number. But I think that will be too much content for you, so I'm skipping it. It's not really useful in the calculus too. Also, I think you will get, maybe if you get another mathematical lessons, because basically engineering you need only calculus, engineering math, and I think that's all. And depends, sometimes engineering math becomes like 1 and 2. I think you only have 1, I think. So that's all for engineering courses. If you want to learn higher math, then it's more science, mathematical science, not engineering. So it's kind of different. Okay. So next week, Tuesday, the quiz will be the trigonometry and the polar until here, the parametric. So not really that much of the content. After the quiz, we will continue where we left on. Because yesterday I'm starting from the parabola, the conic sections. So let's see if we can handle the conic sections. Maybe some, yeah, hopefully parabola and ellipse, hopefully. So again, let me draw for you. Let's say this is a cone. By the way, in the calculus 2, you will learn how to draw the cone. So you will have x, y variables. It's called the quadric surface. So it's called the quadric surface. It has several forms. If you want to know more, you can type in quadric surface and you will see some image. Okay. This is one of the quadric surface. It's called the cone. We have several, including, it's called paraboloid, hyperboloid, and so on and so forth. Okay. But let's see this cone. So as I mentioned, if you are cutting here, you will get a circle, right? With the same plane as the base, right? The base is circle, so this is also circle. If you cut straight, if you cut a little bit like this, okay, you will get this is ellipse. Ellipse is double L, okay, and this is circle. And if you cut like that, it will be parabola. So you need to imagine a cone, and then you cut the cone, and you'll see the cut will be a parabola image. And then the last one is if you have, let me draw maybe here. I should be symmetrical, but I think I made a mistake from the black line, but should be this is the hyperbola. So this is the hyperbola. Okay, yesterday I mentioned the parabola, but let me review a little bit. So parabola, you may know the parabola from this expression, but if we are using geometry, okay, so in geometric definition, parabola is a set of all points in plane that are equidistant from a fixed point F, the focus, called focus, and a fixed line. Yesterday I called D the directrix, but in your textbook it's with the L. But let me just borrow the textbook. So L is the directrix, but the same meaning. Notice that I'm not drawing the XY axis because I want to make sure that this is by a perspective, this is geometrical, not defined by the XY axis. Okay. So this is L. Let me use the red color. Maybe this is the phi, the vertex. Yeah. Oh, quite nice. Okay. And this is the focus. So the equidistant means if you have a point here, so in anywhere of this parabola, the point, okay, it will be equal. Yeah, so it should be equal. So this is the P. Yeah, all same P, okay? So you move the P, your distance from the focus to the parabola, and from the parabola to the some line here will be equal. So that's the definition by geometric perspective for parabola. So in conic sections, we are not looking the parabola as we are usually looking at these expressions, the polynomial expressions, but we are looking at the geometric expressions. So let me write the PF is actually the same as F, and let's say this L. Okay. Okay. Now, if this is equal, let's say the P, small p, okay, and this is also small p, okay. And if we write the focus as the focus is, let's say 0p, okay. So the directrix, the L is y equal minus p, okay. So this is, so if imagine you have a line here, this is p, this is minus p, okay. The distance is the same p, but if you imagine this is the 0 here, this is negative, this is positive p. So this is parabola for p greater 0. If p less 0, then you just switch the parabola, okay? And the directrix will be above, switching the negative to positive, okay? So parabola for p greater 0. So PF will be let me draw this line so that you can see the 0. Let's say this is y. So PF is, by the distance formula, yeah, the x squared plus the y minus b squared. So basically, if you see this p here, okay, so this will be y minus b, this is x, then this should be, okay. Okay. And the distance from point P to L. We can say that this is the y yeah, y minus b. So from this y and plus this minus b, that is the absolute value because it's distance. So this, so we can say that this is also y minus b, sorry. So this should be y plus b. So the distance pf, this is just reviewing the yesterday. So x squared plus y squared plus 2by plus. And then solve this, and we can see that x squared is 4by. So the expressions for parabola becomes x squared equal 4by. P greater to 0, this okay. When you switch the parabola, let's say it become this one, the directrix become here. This is the directrix, and the focus is here. Okay, let me. Okay. Okay, but parabola is not always this and this, right? We can also have the left and right. Okay. So we will have also the still parabola. Y squared is 4px. So if p greater 0, then it will be and p less 0, it will be, and the directrix will be in the front of the vertex. It's always like that. And the same definition, like the distance should be the same, the focus. So this is L, this is focus, this is focus, this is L. Let me give you a simple example for this parabola. Okay. So this, okay. So these two, okay. Either the y squared for px or x squared for py. So that's two form of parabola. Let me give you some example. Parabola equation 6x plus y squared equals 0. Find focus, directrix, and sketch the graph. But for parabola, I think because you already know how to find, maybe if the parabola has a root, you can find the roots and also make sure that the graph is correct. Also, if you want to use your calculus to find the minimum maximum value, that's also fine. It's still possible to find. But here, finding focus and directrix is purely based on the geometric perceptions. Okay? So you can draw first, and then if you still maybe do not really convinced with the sketch, you can try your calculus and try the sketch based on the calculus, and you can compare. It should be the same. It should be the same. So to find the focus, what we do is we just put the equations. Oh, so let me write the equations. This become y squared negative 6x. Okay. Remember that we have the y squared is 4px, right? So 4p is negative 6. So p is negative 3/2. So it's negative. So it should be, if this is negative, so it should be like this, right? Open to the left. So maybe just a quick illustration to give the information that this is f. So f will be negative 3/2, 0. And the directrix x equal 3/2. Okay, remember that in geometric perspective, we are always treat the vertex in 0. So we may draw this like that. And this line will be x equal 3/2. And this will be negative 3/2, 0. But remember, because we are in not in particular x or y axis, so this definition is really purely geometric. So when you translate to the real x, y axis, it may translate to the real x and y numbers. But the distance here is the same. It's similar. So if you just asking to draw and finding the focus directions, you can draw like this in your exam. That's fine. Not really like smooth or really plotting the graphs. Okay? Not really that necessary. Okay? Okay, some additional notes, okay, regarding the parabola. There is terms called the focal diameter. Let me draw in the other graphs. Let me draw here. I will draw bigger. Let me use the blue. Let's say this is L. Let's say this is parabola. So our focus is around here. Focus. Let's say this is another point Q. Let's say this is P and P, okay? Because I make this P, this P. So this this F and Q. Well, let me draw F here. So this becomes 2P. This whole part is called locus rectum. Its length is called focal diameter. It's 4P. So the length of the focus from the point here to here, and it's passing by the focus. It's called the locus rectum. The length is called the focal diameter. Okay, I think that's the basic concept for the parabola. So basically, in the conic sections, most of the problems are to sketch the conic sections based on geometric definitions. Okay, so that's parabola. The other conics will be the ellipse. Let me write the definition first. Definition: set of all points in the plane the sum of distance from two fixed points. Let's say f1 and f2 is a constant. Those 2 points are the foci. It's the plural of focus. Foci of ellipse. Okay. If the words are confusing, let's just see the graphs. So meaning, let me make a point here, P. This is also a point here. And let me draw the focus here and here. F1, F2. So F1, P, and then F2, P. It will be the same as okay. Hope you can get the idea. Okay, what does it mean? Okay. If you move the P anywhere you want, F1P, PF2, this total distance will always be a constant. When you put here, the distance here and here is the same as this distance. Anywhere your point, the distance will be the same. That's the definition of ellipse. Interestingly, if you want to try, let's say you have a thread, okay? And then you have just a pencil or a pen. You can fix this point A, point B, and then you can use this thread and pen to draw an ellipse. And it will be an ellipse. And make the A be fixed constant. You can try it very simple. Okay. I will make another ellipse. And make now I need X and Y. I think it's not really perfect. Let me try one more. Okay, I think now it's better. Okay. It's XY. Let me make the P here. XY 0. And then we make the focus is the first one here, the second one here. And let me make the coordinates is -c. And this one should be the C. Okay. Okay, now based on the definition, so distance from P to F1 plus distance from P to F2 is a constant. We let the constant is 2a. And based from the distance formula, we get the x plus c squared. So distance here is this squared plus this squared square root, right? Let me move all to the bottom. Let me move the other one to the other side. Let me square both sides. It will be really long. So x squared 2xc plus c squared plus 4a squared minus 4a then this will be plus Okay, now we can simplify, grouping all the same variables. You will get this for A. The other will be canceling each other. Let me check this, and this, and this, and this, and this. Right? Okay. Now, let me move this part to the other page. Now we divide by 4 and then squared. So divide by 4. And then squared. Squared. So this part will be a squared x plus c squared plus y squared equal let's solve this one. So a squared x squared plus a 2a squared xc. Now we group all the variables, same variable this and this, right? So we have a squared minus c squared. And we group, we cancel this, right? This. And we group the constant. The constant will be a4 and a squared c squared. So a squared minus c squared. And then let's divide all with this fractions. So this will be x squared over a squared plus and to make it simple, let b squared is a squared minus c squared, with b is greater than 0. So we get the x squared plus y squared. And this means a greater than b. From here is actually, we can see, and that's why a greater than b, we can also see from the picture, it's bigger in the x-axis. Okay. And you get the formula for ellipse. Anyway, for the ellipse, let me write some notes for ellipse with center at origin, meaning it's 0, 0, right? So first the equation. So the vertex will be, let's say, if the A is greater than B. Okay. So the vertex, or the value, maximum value at the x is A plus minus A. The major axis, the length is 2A. The minor axis is 2B. And foci is plus minus C, where C squared is A squared minus B squared. The graph will be like this, okay? The other, it depends on you, okay? I think yesterday I'm showing you if B is greater than A. So we are putting the same equations, but make it B is greater than A. But because the textbook use the same equations, but different condition for A and B. So for example, if we switch the A and B, so x squared becomes b squared, and then y squared becomes over a squared. So it's still the same, a, b, 0. Okay, I hope still understand what does it mean. Okay, yesterday I'm showing you the same a, b, but different results here. But I'm making it the same. A is always greater, but I'm switching b and a. Okay. And the vertex will be 0 plus minus a. The major will be 2a, but the major will be the vertical. Let me write, this is horizontal, and this is vertical. And the minor axis will be 2b, is the horizontal. And the foci will be 0 plus minus c, where the c is the same, is a squared minus b squared. Okay. I think to understand or to simplify, you can just pick one. I think this one is by your default, and the other one is you can switch. Okay? You can switch A, B. Okay. Okay, let me give you an example. Okay, so ellipse equation is x squared. So find foci, vertices, major and minor axis length and sketch the graph. So if you get this ellipse, then nine is greater than 4, right? So A is 3, B is 2. So C squared is 9 over 4 is 5. So C is square root of 5. Or plus minus in this case. So foci is plus minus. And then the first is plus minus 3. Major axis length is 6 and minor is 4. So vertices will be here around -3 and 3. And the foci will be here is around negative there. 0 and this should be 2 and -2. This is F1, F2. Yeah, I think as long as you can just draw as ellipse and then mention the important point that should be fine. Okay. Okay, another notes for ellipse. So let me write the equation or we have E as eccentricity. E equals C over A, where the C is C squared, A squared minus B squared. And E will be from 0 to 1. What does E actually represent? You know, the ellipse, we can draw ellipse like this, or this, or this, right? So the eccentricity will determine the shape of the ellipse. The bigger the E, the ellipse, if your ellipse is from this the major axis at x, it will be more, the less eccentricity will be more similar to circle. The highest eccentricity will be more stretch in the x-axis. Yeah. So let me illustrate what does it mean. So let's say this is eccentricity equal 0.1. And this is eccentricity 0.6. And this eccentricity is 0.8. Okay. It's just an illustration. It's not representing the real E, but just to show you that the more E getting closer to 1, it's getting stretched. Okay? It's getting more ellipse. And if it's less, then it's getting more like becoming circle. Okay. Yeah, I think that's all for the ellipse, or parabola ellipse. The key idea for all the conic section is just to know the basic geometric equations. Okay, and to sketch and find the important points. Okay, like a focus, the vertex. Okay, I think that's all for today. Is there any questions? I will give you some PDF files for the polar and parametric to help you more exercise. I think I already give you the exercise for trigonometry, right? And you already sent me some PDF. Okay, I think that's all for today. If there's no questions.